Step 15 is assembling the spool holder. Well, without further ado, let's just open this up. So the BIQU B1 is going to be compared a lot to the Ender 3 during this video, partially because it's about the same size and a very similar kind of look, but there are some key differences that set it apart and make it a great value. So we have a little filament spool, a SD to USB card reader, SD card, and a micro SD card. I think this is just the SD card adapter. This little reader takes both of them anyway natively, so you don't really need to use the bigger to smaller adapter. We have a manual and a little after service card for warranty. This is the X carriage. Some braided sleeved cables. A duck. Any of you familiar and seen the other videos that we've talked about big tree tech stuff, they include these little rubber duckies and everything. This is going to be one of the trolleys that rides up the Z axis, I believe. Okay. So that's a 2040. In this sleeve is the lead screw. Another 2040 for the upright. Two 2020s. There goes my knife. Bag of assembly components, screws and little brackets and whatnot. A USB-C cable, we'll talk about that a little bit more later. Flush cutters and Allen keys, power cord, part for the filament spool holder. Here's the other trolley. So this one has the extruder on it, so this would be on this side over here from your perspective. And the lever on this is metal, and there's a little threaded insert here for the coupler to go on for the Bowden tube. And we have a firmly mounted filament runout sensor. We have motor, not even sure which one that might be for. Another one in a beefy bracket. Another metal bracket. Okay. And then the base. And the base has the hot end kind of pinched underneath it here. There we go. Okay, so there's the hot end, the Bowden tube for the hot end, and then the little coupler that I mentioned that goes into that threaded part of the extruder. The base with the build plate, screen and all of that, everything built into this bottom piece here. And one last piece for the filament holder. I think that's it. All right, so first things first, I'm gonna open the manual. And right away, I'll just address one quick thing that you might notice. If you've seen any other videos on this printer, you would notice the purple color that they've used on their components, and we have no purple here, so we've spec'd ours out to have black only. Purple's kind of an acquired taste. Love it or hate it. The manual is actually quite nice, pretty straightforward and easy to follow instructions with nice pictures. So this should go pretty smoothly, and it's not my first rodeo. Before we get building though, let's just address a couple things. So the build surface here is like a spring steel sheet, very thin, with this textured powder coated kind of finish. I'm not exactly sure what material this is, but it looks very much similar to the powder coated PEI that we've seen on some other build surfaces, like on the Prusa, for example. And a magnetic sheet is adhered to the heated bed, and this thing snaps right on that, real nice. So that's kind of cool that we're starting off with spring steel. And the y-axis is running on two 2020 rails, so providing a lot of left and right stability instead of a single rail down in the middle. We will need to, of course, tighten the eccentric nuts and whatnot to make sure that that's riding nice and tight on those rails. Pull these out. Big leveling knobs to level the heated bed. And yeah, there is some slop in the wheels. They're loose from the factory, so we'll want to make sure we double back and tighten those up as we go through the build process. The heated bed also has a strain relief cable on the back. Sorry, strain relief for the heated bed cable going into the back there. And then this nylon sleeved cable runs into a grommeted hole on the back of the printer. On the left side here, we have the USB-B port, so like printer style USB port on the side with the micro SD card reader. It's got a U-disc, so you can actually put a USB stick in here and another spot for a micro SD card. So this is where it gets interesting because it's using a unique screen that we'll talk about when we get this thing built and powered on. But for now, let's at least get this protective plastic off of here. Oh my goodness. It was tucked into the corner there, so we'll have to clean that up. So step one is to plug in the heated bed. Now on the new revisions, a little newer than the manual, the heated bed cable is already attached. It's not a Molex style connector that plugs in, and the strain relief is already attached. So we don't have to do any of that. So we can skip to step two. Step two says to take this bracket and one of these 2040s. These 2040s are identical. This particular step doesn't indicate where this hole should be. If it should be placed in relation like this or like that. So I don't know if it matters, and they just made them both so they're interchangeable left to right. The one side definitely does matter. So the bracket is like this, and we're going to attach this like that. And there are two threaded holes here for these bolts to go through. So we'll lay that like that. And we're gonna need two M5 bolts, so we may as well start unpacking this. Each of these bags are actually nicely labeled, so you know exactly what sizes are in each, and they're labeled with the step number. So we're on step 2, so it shows M4 by 8s for step 2 and 3, so we'll need those soon. And the M5 by 16s for step 2 and 3 as well. So we need 2 of these black M5 by 16s. And the Allen key. And we're just gonna bolt through the side of the 2040 into those threaded holes we pointed out. And then step 3 shows us bolting through the bottom into the bottom of the rail. Now there was a little bit of play in these side ones. If I loosen them, we can actually see this thing sliding. So I'm gonna leave them loose. I'm gonna tighten these up tight, and then I'll tighten these ones back in. So for step 3 in the bottom, we need M5 by 10s. So where are my other, there we go, M5 by 10s for step 2 and 3. We need 2 of these. Now I'll tighten these side ones back up. And now this is going to attach to this side of the printer. To the right of the printer if you're facing the front. So my left, your right. And there are threaded holes, there's 4 of them just behind the fan on the side here. And it's going to bolt through using these 4 holes there. And it says we need an M4 by 8 for each of these 4 holes. So that would be these silver M4 by 8s that are listed for step 2 and 3. All right, step 3, we need the other upright here. And this other bracket, this one has the Z motor in this case going on the side. Now, for this upright, it is important where this hole here is positioned in relation to the bracket. So looking at the picture here, the hole should slide inwards like this so that that hole is furthest away from the body of the printer, if that makes sense, okay? So that goes in there like that. And we're gonna bolt it in the same way we did before. I'll put those 2 in, leave them loose, tighten these bottom ones. And those are all M5, I think there's 2 different sizes. Yeah, M5 by 16 and M5 by 10. So then we're gonna take these other 2 silver M4 by 8 screws, 4 of them, and we're gonna use them to bolt through here, just like we did with the other side, into the side of the case. So now that we got that bracket installed, I may as well go ahead and connect the Z motor there. And then the Y limit switch is already connected, pre-connected into the case. All right. So there we go. Next step. Step 4, we're just going to connect the wire into the back of the Z stepper motor. Okay. Step 5, we need the lead screw, the coupling device. So this actually says step 4 on the bag, but that's okay. It's the only coupler we have. And we're going to, coupler has a big side and a small side. So this pole here has a flat surface ground on it. So we're going to line up these set screws, or at least one of the set screws, with that flat surface. And we might have to actually loosen them before we can even get it on here. Let's see. There, nope, there we go. And then slide the lead screw in. This one we're probably gonna have to loosen. I'm just gonna tighten the bottom set screw to kind of anchor that onto the post. Like that. So quick note, when you're tightening these set screws, I would not suggest you use the ball end of this. Use the squared off end. It has a little bit better bite. They'll have a tendency to strip. And then we'll loosen these top 2 set screws to make sure that the lead screw is nicely planted in there. There we go. And then tighten them up. Again, flip to the square end. Now these don't need to be crazy tight, but you want to make sure that they're obviously tight enough that things aren't slipping in there. So step 6, now we're going to start assembling some of this. Nope, not this. Some of this. So the stepper motor here, yep. So for this assembly that is going to ride up and down here, we need the X stepper motor. That guy goes through the back like that. Make sure that you have the connector facing some direction that you can actually plug cables into. I'm going to have mine facing down. Do they specify? They don't specify, but the picture does show it facing down. So connector facing down like that. And there's going to be 4 screws in the front there. These screws are going to be labeled step 6. So a bit of a misstep, pun intended. So step 5 just said to plug in the heated bed. We're on step 6, and the screws that I need are actually labeled step 5. But there is the hex standoff here. It's the only one we have, and this is the only step we use it in, so this must be right. And then we have these 4 small M3 screws that are going to mount the motor to the bracket. All right, so we've got 1, 2, 3, 4 screws holding the motor onto the bracket. The connector is facing the bottom, as I said. And now the standoff, there's 2 threaded holes here. It shows the standoff going in the bottom threaded hole. They call it a hexagonal isolation column, otherwise known as a standoff. So step 7 shows you the ends of this cable. They're actually labeled, and they have a bit of a table here to expand on what these labels mean. So there's X, and it's the type of connector for a stepper motor. So that's going to go onto the one we just installed in the bracket. E for the extruder, which is the other one on the bracket here with the extruder gear. FLD, which says FLD terminal. It is 3 pins. So that is probably going to be the, yep, that's going to be the filament runout sensor. Filament something detector. Anyway. And then there is one more that says Z. And that will be the Z limit switch, which is on here. So that's a little bit different. You know, we've seen many of them having the Z limit switch affixed to the column here or to the side of the printer. This is actually on the carriage that rides up and down, so it's tucked in there. So now we're gonna take this entire assembly and slide it down the top here. The lead screw obviously goes in this threaded insert. And line the wheels up with the upright there. And then I'm just gonna turn the lead screw slowly by hand to kind of thread it in there and drive this guy down. And the eccentric nut is really loose. There's a lot of play between this and the upright. That's fine. We're gonna tighten that up later. I'm just gonna lower it a little bit here to kind of clear this top area. Okay. And then we may as well connect the rest of these cables. So flipping this around on the back, easier for you to see, harder for me. We've got this larger cable, or sorry, larger connector. That's gonna go into this guy here. And it only goes in one way, so make sure yep, that should be it. It is tight, goes in one way. And then this is going to run up here underneath this, would probably be ideal. And then we're gonna connect these to each of the points we just discussed. So we have the extruder motor. We have the X motor down here. Flip this that way. We have the filament runout sensor. And we have the Z limit switch. Whoop. All right. Okay, that looks good. So now we have just finished step 7-1. Step 7-2 is talking about the other trolley here. And this is going to obviously go on the other side, and the plate goes on the front of the machine. So let's flip this back around for you. The plate is going to go like this, and our eccentric nut on this one is on the inside. Now this one is already nicely tightened, actually, riding nicely. And there's these pre-installed hammer nuts on these screws here. And these screws are what we're going to mount the cross member to, the X-axis. And what we did right there, we covered step 7-2. 7-1 was talking about the cabling, and 7-3 is connecting the cables to the back of the box, which we did at the beginning. Step 8 says we're gonna put the top cross member on here. Now, these two 2020s are different. So one of them only has these countersunk 2 holes on either end. That's for the top. This one here has these offset countersunk holes, and that's the X-axis. So we'll take this one, countersunk holes up. That's our top member. We're gonna need some M5 screws, and since we're on step 8, we'll just grab the M5 screws labeled step 8. There we go, M5 by 25. There are 4 of them. And we're just going to drop these in the top and thread them into the uprights, and then tighten everything down. All right, so I've tightened those down, and I've made sure that everything's kind of flush and squared up as I've done so. So we're done that. Step 9 shows what they call the X slider sheet. This is the X carriage. And it shows them attaching the belt and what the belt path will be. So our belt here for step 9. Now I think it makes most sense to demonstrate this when we have an X-axis to attach it to. So I think we'll park that for now and show you then. You know, the cord kind of has a tendency to curl up when it's not under tension. I just think it'll be easier to show. So skipping step 9, going to step 10, we have the other 2020 here. And this is going to bolt onto these. We need some screws to bolt through the front. And this is going to go like this. So the 2 countersunk holes go on the same side as the extruder. And on the back, there's another countersunk to clear this screw head, and this one clears this. Now these hammer nuts, you want to make sure that they're horizontal so that they actually slide into this groove. Like that. And then we're going to screw through the front here and here. But just to make sure that this stays, I'm going to spin the screws that had those hammer nuts on them to kind of engage those. So I'm backing the screw off to loosen the hammer nut. You can look through the back and see the hammer nut spin to make sure that it's properly engaged in the channel. And through the side over here. Luckily I can kind of coax it to spin. So I tighten those two first, and then add that guy there. So we need 2 more screws for step 10, M5 by 18s. These should go through here. All right, it's going nowhere. And at this point, I'm just gonna take a second and tighten this eccentric nut here so that I don't forget to do it afterwards. Normally I would say tighten it until, when you spin the wheels by hand that things move and all the wheels are rolling and nothing's slipping at that time. But because we have the lead screw here, we can't really check that way. So I just, I can't spin this wheel by hand because there's tension there. This one at the bottom is spinning freely and this one is spinning freely. So I'm gonna apply a little bit more tension on the eccentric nut. And you always have to experiment with which way is actually making it tighter versus looser. There, that's better. Okay. So we just want to make sure that it's tight enough that there's no slop, right? So for step 11 and 12-1, we're going to route the belt and install the x-axis tensioner. And step 12-2, we're going to tension the x-axis tensioner. Okay, so we've doubled back at 1 step and we're going to install the X carriage here. So there's 3 wheels. The bottom one is the eccentric nut, as always, and this goes like this. On the bottom here, you see these 2 fingers. That's where the belt is going to kind of lock into. These little clamped on pieces go through there like that, and the belt gets routed. But we'll cover that in just a second. So first, we're just going to slide this on the end here, like that. And then we're going to route the belt. So the teeth of the belt, they're going to be face down, and I'm just going to slide them in the aluminum track underneath the wheels. Okay, like this. And now those teeth engage the gear on the end, route them over top of the standoff. And on this end, don't worry yet, because there's another piece coming here. We're gonna have a belt tensioner and an idle wheel there. But for now, just kind of move this guy along so that I have some more slack there. I'm going to slide it in those little fingers on this X carriage that I mentioned just a moment ago. It is tight clearance to get that slid on, so if you're having difficulty, you can slide them on with the X carriage here off the 2020 rail. So as I said, teeth down, around the gear, over top of the standoff, and then through the little finger. If I flip this around, should be able to see where it slides in the fingers here. And there, as I said, there's very little clearance between those fingers and this 2020 rail. But once they're in the middle, there's that groove that gives them plenty of clearance. Right? So you can feel free to install that off the printer if you're having difficulty. And now on this side, we need the belt tensioner and the idle wheel. So this is the bag for step 12. Has that assembly kind of pre-built for us. We've got 2 more hammer nuts that we're going to use to attach this. So this piece is going to go like this, and they need to be in this groove, and we need to make sure that they rotate 90 degrees to kind of lock that into place. And we'll route the belt over top of this idler. So I loosen them and then kind of rapidly spin. And you can check through, well, I can tell that that one engaged obviously, but you can check through here to see if it's engaged. This one we're kind of blind. You have a little bit where you can see through the end, but if you just loosen and then kind of rapidly tighten, you can see it twist through that little slot there. So now that's not where we want it to be. We will loosen those a little bit and put tension on this to put tension on this belt, but generally that's how it's going to get installed. So you don't need to put a lot of tension. You can kind of wedge something in here, like a larger Allen key, making sure that the belt stays on your idler. You can wedge an Allen key in here and put pressure against the 2020 like that. You can kind of see it sliding. But honestly, tight finger pressure, and then tighten both of these back down. And then just slowly slide this along and make sure that the belt isn't rubbing anything. So you can have this kind of slightly angled up or down if you're not careful. And I've seen belts kind of get shredded on the sharp edges, but this looks like it's tracking well. And the wheels on here, this helps demonstrate the fact that I spin any one wheel and all the wheels are spinning, they're all contacting the track, and they're nice and tight, and there's no slop in any of that assembly. So that's the level of tightness that we want for the eccentric nut there. So the belt and the tensioner, those steps were 12-1 and 12-2. On step 13, we're gonna bolt on the hot end to that assembly. So let's unwrap this guy. Careful, there we go. And let's just take a couple minutes to talk about what we see here. So we have a clear, it's not 3D printed, it's like an injection molded fan shroud with an outlet all the way around the nozzle. And then the rest of the cold side and the heat sink is all kind of buried in there. This is nice. So you've got 2 cooling fans on either side, and then you have this curtain of air all the way around the nozzle. On the, this would be the back. On the front, we have the cooling fan, and that blows against the heat sink. On the back, we have a 3D printed, looks just like a spacer. Doesn't really seem to have any other purpose, but it's protecting PCB on the other side of there. And it provides kind of a gap so that we have clearance for this little limit switch. So that's our X-axis limit switch. It's attached to the hot end, and I think it's gonna press against here, but we'll find out. And a little bit of a window where you can see in there. On the top, we have our Bowden tube, obviously, and we have the USB-C socket for our cable to our hot end. So this is just mounted with 2 screws on the top here. Step 13, they're M3 by 8 millimeter. And we will just bolt him onto here. Step 14, we're gonna connect the Bowden tube to the extruder. Make sure you don't put this over top of here. You'll have a bad time when you try to bring that down. So underneath, and this just screws into that threaded insert there. You can use your wrench to give it a final tightening. There we go. And just make sure that the Bowden tube is pressed all the way into that collar. That's good. Step 15, we're going to screw the spool holder through the stand for the spool holder and tighten the nut on the other side. Okay, step 16, we're gonna attach the filament spool holder to this bracket like this. Okay, and then this again has hammer nuts already installed on the bolts. So they, in the picture, show it going this way. So with the kind of the open face of this and the back of the spool holder facing out. And then, like with the rest of the hammer nuts, just loosen them and then twist rapidly and check down the slot to make sure that they've rotated 90 degrees and they're properly engaged in the channel there. Okay, step 17, this is where our USB-C cable comes in. So they've chosen, they're clearly using like a breakout board inside the bottom of the control box that leads from the SKR board in there to a daughter board of sorts that changes the pinout from the SKR board into a USB-C and the pinouts within that. So all of our power for our fans, for part cooling fans, the heatsink fan that's always on or at least on when things are hot, and the hot end itself, the heater cartridge, the connection for the thermistor, everything is coming through this one cable. So USB-C plugs in there. We're gonna route it similarly to the Bowden tube under here. You could even zip tie these together, which is pretty common. And so on the back here, the extruder bracket has a little slit in this metal bracket. And so we can use that slit to slide a zip tie in and then zip tie this guy on there. And you don't want to be pinching the cable. You can damage the conductors in there. And then we'll snip off the excess. Okay, there we go. Make sure it has enough slack to kind of follow the Bowden tube. Reaches from one end to the other. You can, as I said, kind of zip tie these two together I think I'll just leave them loose for now anyway. Take this little tag off. And USB-C cables, I mean, they're bi-directional. It doesn't matter. The ends are identical on both sides. And as for both sides, let's plug the other one into the back of the control box. So this is where that breakout board would be. There's the USB-C spot. So we'll click that guy in there. It's actually labeled Smart Filament Sensor, and there's a separate connector on the back. It's interesting because we haven't connected a separate smart filament sensor cable. Everything ended up coming to this large cable down here, even though it broke out up here. So I'm not sure if that's referring to a different filament sensor of sorts, but we'll have to see. All right, step 18, we have the Z-axis limit module. So this module here bolts onto the back of this extrusion. So this is why it was important that that threaded hole on this side was furthest away from the body of the printer. That's where this guy gets bolted onto. The screw's already pre-installed there. We will be able to screw him into that threaded hole. Now, facing upright, of course. So what this post does is it gives us some adjustability in the height where the Z-limits trigger will be triggered. So we can actually back this screw off, which has a tension spring so that it doesn't rattle around and stuff during use. But we can raise this or lower this to adjust what our Z-limit height is. Because this switch here will come down and contact that. So if we raise it up, it'll give us more clearance between the nozzle and the bed. That's helpful if we have a different bed surface on here. If we slap glass on here and we're adding 3 millimeters, we would then have to raise that approximately 3 millimeters. If it has enough length in that screw, or replace it with another, looks like M5 screw that's longer to give you that clearance you need. But that's kind of cool that it's not a fixed point and then you have to like print a bracket or something to give you adjustability. So that's all there was to that, just bolt that guy on there. Step 19 is, well, power plug. So on the back, we've got your standard, don't know why I turned it around. On the back, we've got your standard power inlet. You do have a fuse in here, so if you do blow a fuse for some strange reason, or if it's not getting power for some reason, check your fuse. Also, make sure that your power inlet, this one is labeled 100 to 120 volt. So that's North American voltage. If you're in a different region, make sure that's appropriate for your region. Especially if you're in Europe or South America somewhere where you're running 220 of sorts, you'll fry this guy in this case. So now let's just plug it in, get it fired up, and let's level our bed. All right, so before we turn the printer on and explore the LCD, which is both touch and encoder based, it emulates the 12864 screens that we've seen on tons of printers like the Ender series. But it's also got a touch screen interface. So it's almost like dual boot, if you will. But before we turn that on and start playing with that, I just want to cover what we have left from our supplies that we built the machine from. So we have 2 spare nozzles in a bag here. They're both 0.4 millimeter, and 0.4 is also installed on the machine. And these are labeled UM2, so they're Ultimaker 2 style nozzles. So just make sure, if you're buying spares or larger sizes or something, make sure you're getting the right ones. We have a bag of spare screws. Great, always nice to have spare bits around. We have our SD card, micro SD, the adapter. And then we have the BLToucht stand. So you're like, well, there's no BLToucht on here. We talked about the little standoff for the Z limit switch. So it's using that for at least Z min. And there's nothing to do auto bed leveling. They give you the screws and the stand to attach the BLToucht to the front of the hot end assembly there. And it's a metal, bent stand. So you can then mount your BLToucht to that, run your BLTouch cables down to the back of the machine, connect them to the board, and then you just enable the BLTouch in the firmware. So the firmware is compiled with those bits already active, and there's a toggle on the menu system that will just enable BLTouch and reboot, and now we have BLTouch capabilities. You'll still need to set your X and Y and Z offset, I'm sure, But that's kind of neat. We don't have to print anything, and that it kind of has a built-in provision for a BLToucht mount out of the gate. Anyway, with all that said, let's turn it on. And it's a color touchscreen, as I said. All right, so we're in the touch interface and we hear nothing. So they are not using temperature sensitive hot end cooling. So there's an option in the firmware to say, only turn on the hot end heatsink fan when the hot end is above 50 degrees or something. So when your printer's sitting there idle, there's basically no fans spinning on it at all. In this case though, the fan is extremely quiet. It looks like a 40mm fan, but it's basically silent. I mean, the AC system in here, the HVAC system is louder. We also have a fan on the side of the case that I can't hear either. So it's nice that they invested a couple extra dollars in quiet fans. We know the drivers are silent because they're using Trinamics. So we should have a nice silent machine to play with. All right, so on the main screen, we see your typical kind of status screen information. It tells us that the printer is ready. We have a menu button. Up the top, we have T0, so that's thermistor 0, so that's the hot end, hence the picture. So it's about 22 degrees right now. The heated bed, the fan, so this, if we turn the fan full, that is the hot end cooling fans. Let's stop those, go back. This is your feed rate. So that, is the printer running at 100% the speed that you sliced it at. And then under print, this is where we'll navigate for files on the flash card. So in here we have the TFT SD. So that's the SD card reader for the TFT, the touch screen, which is right in the side here. We can confirm that by throwing in the micro SD card it came with. It says card inserted. Let's click on that. And now we see the models that are from the factory. Going back out, we have the U-disk, so the USB disk. It's labeled U-disk in the side of the screen. And we can load files from there as well. And then onboard SD is going to be the one that's on the main board, so on the circuit board, which is halfway towards the back of the printer there. And again, I can pull the SD card out, throw it in there, and just confirm. One thing I'd like to mention here is that there is no clearance around the SD card slots. And what I mean by that is there's essentially no empty gap there where I could accidentally slide the SD card in there and lose it inside the control box. We've seen plenty of other printers that have a large gap there, and if you're not careful and don't slide it in the right slot, you've now got to take the case apart to get your SD card out. So onboard SD, the back one, there it is. Now we've got models. Slightly different, visual representation of the data that's on there, but the same stuff is there. All right, pull that out. Let's go back out here. So let's go into the menu. And so heat and fan, so we can preheat. And we've got some settings here, some presets, I should say. And we're used to on the Marlin menus having like PLA and ABS are basically 2 settings. This one happens to have 4, and it shows you what the heated bed for each one is and what the hot end is, which is kind of cool. Go back. We can just do heat and just set the temperature individually. So I can go nozzle, and then I can just toggle it back to heated bed. So T0 versus bed. So that's telling us which one we're currently modifying. And cool down just kills any heat settings and sets them both to 0. Under extrude, this is where we're going to be able to manually load and unload, like extrude or retract filament. You're only going to be able to do that when it's hot, obviously. Emergency stop, so if something's gone wrong, your print has come loose and it's smashing into it, hit that button. So terminal, this is where you can send specific commands to the screen. I'm not going to pretend to know what commands we can send here. I'm not sure if it's like standard G-code commands that it'll take. Maybe I'll play with that in the future. Custom, likewise, I'm not familiar with this, but let's take a look. So disable steppers, does that actually just do the disable? Yes, it does. Release SD card, technically nice eject kind of thing, eject before removing. Restore leveling, save to EEPROM defaults. So this is kind of like your normal initialize options in the Marlin menus. And that was, so under settings, so we have some screen settings where we're probably going to be able to do like screen calibration. We can rotate the UI. Not sure why we'd want to do that in this particular environment, but since this screen could be used in many different machines with different orientations and whatnot, that's kind of cool. Touch screen adjust, change the language, turn on or off the beeping sounds. So touch sounds are off versus on. We'll leave this kind of by default. The toast notifications there, that's that little notification we saw at the top that says SD card inserted. Black, not sure what that's going to do. Oh, let's see, Marlin Simulator background. Okay, so the Marlin Simulator is the second kind of flavor of this firmware where we can flip to that emulated 1286p, sorry, emulated 12864 screen. And you can set the different background colors for that. We'll just leave it at default so I can show you what it looks like out of the box. And then green. So this is the font color, okay, for that same emulation. So still in settings here, let's look at machine settings. Okay, so parameters, so these are your kind of your calibration parameters, steps per millimeter, XYZ. You can set the driver currents. Since we are using the Trinamic drivers and they're on a SKR 1.4 board in here, they're likely have the jumpers set for UART mode, so we can actually send G-code to them and make physical changes to the drivers, like in this case, the current that they're drawing through G-code commands. And it does it likely for us. We just set the current and it sends the appropriate G-code command. So we're not gonna play with that, but that's where a bunch of calibration and tuning will come in if you want to, if you're so inclined. Custom, this is just the same stuff as before. LED color. So here, this is where we can actually set the different colors for the fan shroud. As I mentioned when we unpacked it, there's this nice injection molded fan shroud and it's kind of translucent. And so this will allow you to change the color. It's kind of nifty. Maybe I'm just going to leave it at white for the duration of this. So under feature here, show acknowledgement in terminals, so it'll ACK responses through serial. You can swap the X and Y axes. I don't see why you'd want to do that unless you've maybe changed the stepper motor or driver or orientation of the motor, but anyway. Auto power, let's turn that on. Not even sure what it did, so we'll leave it off. Filament sensor, it's currently enabled, and we're going to leave it like that. But if you don't like the filament runout sensor, or if your sensor gets damaged, it might report false positives. Like it might say it's out of filament when it's not. So then you can just disable it here. So you've got the smart, which we saw on the back of the unit. There was a label for smart filament sensor. We're not utilizing that. So you could turn it off if you were having those difficulties, as I explained. We'll leave it on. Move speed, just going to leave it normal. Interesting. Start G-code before print and end G-code. So this reminds me of the settings we set up in Cura, for example, of our pre-print G-code sequence to run through, like maybe a purge line and stuff, and then our final G-code to bring the bed to the front maybe or something. So perhaps it's referring to something like that. That's actually sent from the firmware on the screen to the printer before and after every print. And I'm not sure where you would define that at this moment anyway. So obviously there's a bunch of reading to be done on this screen and the options therein specifically. It's not necessarily specific to this printer, it has to do with the screen we're using. Persistent status info, yes, I always want to show that. If I turn that off, maybe these top guys will go away, or maybe on the main screen where we saw the status info. So I'll leave that. Files viewer list mode is currently off. So that was when we were navigating through the files. So it'll be interesting to see turning that on and off, what the difference is there. ACK notification style pop-up I'll leave that. Rotary knob LED. So just like the hot end has, the rotary knob here has an LED built into it. So if we turn that on, we're set to white. Rotary knob LED idle on. I'm not sure what that does, but we've got white, red, orange, yellow, green, blue, indigo, violet, and off. So I'm gonna also set that one to white, just for, whatever. Let's set it to something else. Let's set it to blue, there. So we can change the brightness of the LCD. You can actually set it to dim after a period of time, which is kind of cool. Marlin mode in full screen, so we're not in Marlin mode right now. I will leave that off, but I feel like it'll just scale it to fill the entire screen a little bit better. And power loss recovery. So this is where it will, when you're printing from a micro SD card, it will keep track of where you are. If you lose power, it'll give you the option to resume where you left off. And then we can restore all of the defaults. All right, connection. So we can change the baud rate. So this would be 115/200. So this is the baud rate of the board. My SKR 1.4s, I set it to 250,000. Disconnect, not gonna hit it. Emergency stop, we talked about that before. And shutdown, this will be interesting. I don't think it actually has like control of the power supply or anything to actually shut the machine down, power-wise or physically. But this might be just to try to stop a print, and this is emergency stop, like a reset, like a kill switch. And last but not least, tuning. So PID tuning, this is where we can fine tune temperature control algorithm, or the parameters for the algorithm anyway, to more accurately control a stable temperature instead of having kind of undulations or major fluctuations. With appropriate PID tuning, it'll be pretty much a flat line. And if you change the hot end or change components of the hot end, heater cartridge, for example, you'll probably want to do PID tuning, at least I would. And then extrude 100 millimeters. So this is something that I would do constantly if I'm calibrating my E-steps. I happen to use 100 millimeters. Measure 120, extrude 100, measure the difference. It should be 20. And use what I calculated as the difference there, or what I measure as the distance, use that in my calculations for my E-steps. I'll double check that we've done a video on that, and if not, we definitely should. We'll do one in the near future. All right, so that was a lot, and a lot that I also, admittedly, as I said, don't understand. So we'll have to kind of play around and see what those options, what the effect of those options are. So for the firmware, let's flip over to what we're calling Marlin mode here. If I'm gonna hit this reset button, and while it's on that screen, I'm gonna press and hold the encoder, and now I've got the 12864 mode, Marlin mode as they were calling it, and then the touch mode, which is what we were just in. So if I go to Marlin mode, there. And so, just a moment ago, we saw the full screen option, so that's where it would probably just stretch this to fill the frame a little bit better. And this would look very familiar to all of us. This is your normal, Marlin environment as far as menus go. And we can see, a lot of the same information in the familiar menu system that we've gone through many times. We looked at some of the options there for the trinamic drivers and the amperage they were pulling, right? This is where we would be able to set that. The trinamic drivers do have Stealth Chop enabled on the firmware out of the gate. Stealth Chop is a extra quiet mode that it has slightly less torque, but in the case of especially a small 3D printer, torque is really not that big of a concern. It can become a concern if you have an extremely heavy bed moving back and forth in the Y direction like this. You may want to turn that off, sacrifice a tiny bit of sound for the extra torque that it provides. And it is really a tiny bit of sound. I'm not really going to go through this in depth. It's things that we've seen plenty of times before, with some extra options for things like lights, which turn them on, turn them off. So I had turned on this is referring to the hot end lights, and I had turned them on previously, so we'll leave them on. Light presets, so it's got the different colors. You can actually set custom color codes in like RGB. Yeah, so I'm going to actually go back into the other menu and try to stretch this to full screen, that option. So that's in touch mode. So that was under menu, settings, features. Marlin mode in full screen, I'm going to turn that on. And then yeah, there we go. So it's just stretched it to kind of fill the screen a little bit more. Yeah, at the end of the day, I'm actually not sure that I like that any better, but now we know what it does. At this point, we'll just make sure that homing works. So auto home. So it's going to home the X, the Y, and then it'll bring the Z down. Now we're doing this cold. I want to make sure that there's enough clearance that it doesn't, ram into the bed. So I've backed that screw off on that standoff to raise it up to give us some clearance. You can also make sure that your knobs are pretty tight, which lowers the bed as well. And while I'm at it, the one eccentric nut, or the series of eccentric nuts that we haven't tightened, if you remember, we checked on the trolleys here, we checked on the X carriage, but under the bed here, there's a little bit of play. The bed wiggles. And so on this side, there are eccentric nuts under here, and I'm just going to give them tightening, and I'll use the same method of spinning the wheel with my fingers to make sure that it's gripping onto the extrusion. So with those tightened now, we have no slop in this bed. Because we did home it, the stepper motors are engaged, so I can't slide this bed back and forth by hand. So on the screen, if you go to motion, at the bottom, there's disable steppers, and that kind of unlocks the steppers so we can slowly move them by hand. And I just want to check that it's moving smoothly. We don't feel any like flat spots or getting stuck as you roll it along. That can be indicative of you having the wheels too tight, so they seem fine. It also makes it a little bit easier to reach under here when this is all moved forward. This back wheel actually is a little bit loose still. That's good. Okay. Put that back, and I'll just re-home it. And then we'll grab a piece of regular printer paper, and we'll do your standard bed leveling. But first, let's get it up to temperature. So under temperature, there's preheat PLA or preheat ABS. We're just gonna preheat PLA. Choosing that, we'll do both the hot end and the bed. Okay, so we can see that the hot end is preheated, as is the bed. First thing before we level our corners, we're going to go to movement and then home, and just home all axes. So then our hot end will come to the front left-hand corner. And I've just got a Post-it note, but I've folded it in half so that the sticky part isn't exposed, so I don't get any sticky residue on the bed. And I'm just gonna use the unfolded portion under the nozzle for the normal leveling routine. So if we go back to, if we're at the home menu here, we're going into movement and then leveling, not ABL, but just leveling. And then it's got those kind of predefined corner pieces and center point, so we can level at each of these. So hitting point 1 will bring us in a little bit from the corner, and then we can go around corner to corner, level them all, level the center, make sure that that's good, and maybe do it a second time. So sliding this under until there's a little bit of drag. There we go, and we'll go to the next point. And the reason we go around twice is as I'm making changes to each corner, I am affecting the other corners just a little bit. You can picture if I'm raising this back corner, it's actually raising this a little bit as well. And if you're not too sure that your bed is reasonably level, you may want to keep the piece of paper under the nozzle the whole way across so that it doesn't end up damaging your print surface. Righty-tighty, lefty-loosey. There we go. All right, and let's check the center. Good. Not really a concern on small beds, but especially on a larger bed, they can have a little bit of a concave shape to them. And so the center, you may find that there's less drag than the corners. And if that is pronounced enough to be a problem, that's really where ABL comes in. And this machine is well suited to ABL. Check out a future video for that. So I'm just gonna go around one more time and double check. Okay, so it's heated up, it's leveled. I'm gonna throw on some PLA and we're gonna do some test prints. All right, so we have 4 prints. 3 of them are PLA, and this is actually Tallman tea glaze, which is PET. This is a food safe, food contact safe plastic. And this particular model is actually kind of cool. While it looks like a decorative hat of sorts in this direction, it's meant to be used like this. And the idea is you line up shot glasses around here and pour the liquor in the middle, and it actually distributes it and fills all the glasses at the same time. Hence why we use like a food contact safe kind of plastic. And it is printed in this orientation. So we are using a Bowden hot end. I'm not certain without taking the nozzle off if the Bowden tube goes right to the nozzle, meaning like it's a PTFE lined hot end, or if it's an all metal. But you print PET at a higher temperature, similar to what many PETGs are printed at. And you do want to be cautious that you're not really exceeding that 250 or so degree range with a PTFE lined hot end. But it printed beautifully. There is some stringing, obviously. This is a much stringier plastic. We could take a heat gun or a blowtorch or a nice lighter to it, and most of that would burn away right away. That can also be reduced by tuning your settings a little bit better for that material. Retract, cooling, if applicable. But as far as layer stacking goes, it's nice, beautiful, smooth surface. So I have no concerns, didn't under extrude or anything, no clogs. It's acceptable from my perspective. So we've got this little guy. He's got sharp teeth in here. Obviously, he is printed like this, so mouth up. And so there's a lot of travel between these pointed teeth, and we do have some wispy hairs in there that again can be burned off. We did use support material for this to support the edges of the mouth. They break off without issue, and that means our cooling is adequate. Otherwise, they could bond really well. And then this, to be honest, I don't even know what it is. Looks like some sort of a statue. And because we do have a bunch of support material in here, comes off relatively easy. There's actually quite a bit on this one. And the whole base here is surrounded by support material because it's not flat. Now this I'm probably gonna need a set of pliers for just to get some, I could probably use some flesh cutters maybe. Yeah, there we go. All right, now I've got a mess, but I've got all the supports pulled off. And you can see there's this like 90-degree overhang here, so we did need supports. If that overhang had a bit of a bevel to it, we'd be able to get away with no supports there for sure. One more support piece. Okay. Again, a couple wispy hairs, and layer stacking is good on here. I don't have any concerns as far as first print on a new printer. And then this, I know I'm going to get raked over the coals for this one. I think it's something from The Mandalorian. Again, I didn't print these, so I have no idea. But it's printed flat like this, and we have, again, a bunch of support material, peels off easy. You will have your normal amount of marring from support material on the bottom. Now this print, interestingly, shows kind of like the mouth did, a couple layers that are just not quite in line with the others. And I'm not sure if that's this random filament we threw on it or as a result of the printer. You know, we may need to adjust the flow rate for that particular material for this printer. So it'll be interesting to get to the bottom of that and do some further prints. But again, you know, turned out fine. So as I said at the beginning, you know, a bunch of this is going to get compared to the Ender 3. They're the similar size. This is 235 by 235 by 270 millimeters tall, so it is taller than the Ender 3. It has a bunch of upgrades that we would normally slap on an Ender 3. You know, the SKR board is a very popular board, in this case the 1.4, but it might be the SKR Mini E3. The Trinamic drivers, another popular upgrade. It has a proper belt tensioner on the Y. You're still using this pull tensioner on the X. Dual cooling fans with that cooling shroud, the lighting options, a unique cable setup for the hot end, and the cool touchscreen / typical Marlin 12864 interface. Myself, I typically don't like touchscreens, but this is nice. I mean, it works well. I like the layout. The menu system makes sense. The icons are self-explanatory, but I'm not also bound to that. I can always flip back to what I'm more comfortable with, for lack of a better term. And it's rigid. You know, the uprights are nice and rigidly attached. The Y-axis being split into two gives you more stability from left to right, so you're not kind of teetering on a smaller, even though it is a 40/40 on the new Enders. You're not teetering on the middle one, so you should have more stability by having the wheels spread further out like that. And I'm just, and it's got the provisions to add the BLToucht, like that bracket I mentioned right out of the gate. And on the back, it's got that dedicated pinout for the probe pins. So you don't actually have to route the cables inside the printer and flash a custom firmware or something. It's already set to go. Just plug and play, more or less. The spring steel was a nice addition. The coated surface on here works great for bed adhesion. You know, make sure you got your leveling down pat and your fan off for the first few layers. The fans were nice and quiet. I honestly have very little complaints. I think it's great, and myself, I could see, you know, me as I refresh my smaller printers in my farm, getting a bunch of these. I wouldn't see the need to do much to them. You know, it's got almost everything I normally add on, the BLToucht, SKR, and the Trinamics, and it's got that filament runout sensor, which is definitely a nice to have if you're doing longer prints than what you have left on your spool. You don't have to really open a new spool, and now you got two partial spools. So that's always nice, less waste and less concern around running out. Oh, and one more thing I'd say is the wire management. You know, we don't have a whole bunch of random wires everywhere, partially due to this kind of big base design where much of it is already enclosed. But we really only have like one nicely sleeved bundle and then the USB-C cable. So that's nice and neat. The USB-C cable, easy to replace. We just go grab another standard USB-C cable off the shelf. So we don't have to worry about, you know, soldering in new wires or whatever if something happens there. I like this printer. Hopefully you'll like this printer, and hopefully you found all of this useful. Remember to like and subscribe. Ring that bell to get notified when we upload more videos like the BIQU B1. Thanks for watching.